there are shortage or limiting of resources, then we use, if more than one resources are in shortage, we use the linear programming. Okay, I upload the lecture relating to the single limiting factor. It is similar to as we discussed in the throughput accounting. It is based on the marginal costing concept, and in throughput accounting, it is based on the throughput accounting concept. So key factor analysis is used if there is only single shortage of resource. If there is more than one resource is shortage, then we use a linear programming technique for the solving the limiting factor analysis or find the optimal production plan. So, linear programming, where there is only one scarce resource, the method above key factor analysis can be used to solve the problem. However, where there are two or more resources to short supply, which limit the organization's activity, then linear programming is required to find the solution. So, you will use the linear programming. Linear programming is a technique that may be used to determine the contribution maximizing or cost minimizing solution to a problem, whether there are two or more limiting factors, not just one. Okay, when at the same time more than one factor exists, we use a mathematical technique that is linear programming. So there, just like a key factor analysis, there is also steps to solve the question. There is two options, that is maximization of contribution or minimization of cost. First of all, we discuss the maximization of contribution, how we will formulate the linear programming, how we will formulate our linear programming solution. Okay. First of all, the step is define the variables. The steps involved in the linear programming are as follows. That is, define the variables. First of all, we want to find what we want to find in the optimal plan. In optimal plan, we want to find those units at which our contribution is maximized. So what is unknown for us? Unknown is units, unknown is maximum contribution. So we assumed at the start what is my maximum contribution and what is my units of the products. Okay. So that is the define the variable. We suppose that what is the value of, suppose we have two products, A and B, and I suppose X is the units of A. X represents units of A and B units is represented by Y. So we assumed how much units, we assumed X units for the A and Y units for the B, and C for my maximum contribution, because I want to find all these three things and we are going to make the solution to find these. Okay, so first of all, I define the variables which I use throughout the solution or solving the problem. Then next step is define the or formulate the objective function. So as I already discussed, organization objective may be maximization of profit, that is contribution. Not to use the word profit, we will use the contribution, because internal decision making is all based on the marginal costing or minimization of cost. So define or formulate the objective function, then we will decide what is my objective, main objective of business. Main objective of business is maximization of contribution. Then I have to formulate the constraints. When we formulate the constraints, constraint means shortage of resources. When we are going to formulate the constraints, it may be less than or equal to or greater than or equal to. Normally, in maximization of contribution, constraints are less than or equals to. Or sometime if how we will know the constraint is max is less than or equal to, I will if the words use up to maximum, then it means the constraint is less than or equals to. Okay, and if the word is used at least or minimum, then the constraint is greater than or equal to. Okay, so normally in contribution maximization case, your constraints are less than equal to, or in minimization case, our constraints are greater than or. Okay, so then we will formulate the constraints. Now, then we have to draw the graph. In exam, you don't need to draw the graph, but I will draw for you for the understanding purposes. So, no, in exam, we don't need to draw the graph. The graph is already drawn. We have to just solve on the points. So, solve the optimal production plan. And now we have to find our optimal production plan. Okay. So, first of all, we will discuss no, the question. A company produces two products in three departments. Details are shown below regarding the time per unit required in each department, the available hours in each department, and the contribution of each product. There are two products, X and Y. Hours per unit in department A is 8 hours and 10 hours for the Y, and 11,000 hours maximum hours available is 11,000. And in B department, labor takes 4 hours for the product X and 10 hours for the product Y. And the maximum available hours is 9,000 in department B. And in the C department, labor takes 12 hours and 6 hours for the Y. And maximum available hours is 12,000 hours. Contribution per unit is 12 and 8 of the X and Y. There is unlimited demand for the X. There is no limitation of demand for X, but the demand for the product Y is limited to 600 units per annum. But the demand is limit only maximum you can sell up to 6,600 units, not more than 600. So determine using the step-by-step approach what is the optimal production plan. So please take the picture of this question. We will solve this question by using all the steps I already discussed with you. Yes, now can I start? Okay. First of all, the step one is define variables. This is our step one, define variables. As I already told you, what I have to define, I have to assume units of product X and units of product Y and my maximum contribution, because I am going to solve, or I am making the optimal plan to find all these three things. So suppose small x is a units, number of units of X produced, and small y is number of units of Y produced. C is my maximum total contribution. I assume the variables because I have to make the equations. That's why I need assumption. Now, next step 2 is formulate the objective function. What is the objective function of organization? Main aim of the organization is to maximize the contribution. So we will formulate objective function. In objective formulation function, we have to calculate our total contribution. My total contribution is C. C represents my total contribution. I said C is equal to unit contribution of X. What is the unit contribution of X? X unit contribution is 12. I want to find the total. I said T represents the total. This 12 is per unit. So for the total purpose, I have to multiply with units, but I don't know at this stage how many units of product X we are going to produce. So I assume the units of X is small x. So I will put here X, 12X plus, and what is the contribution per unit of Y? That is 8. I will assume Y. It will multiply with Y. Y, what is the Y? Y is the number of units of product Y. But at this stage, I did not know what are the units. That's why I suppose, or I multiply it 12 into X and 8 into Y. Now, next step is step 3. And step 3, I have to calculate or formulate the objective functions. Formulate the constraints. I have 3 constraints. In all the departments, labor is limiting factor. Department A. Maximum hours available is 11,000 hours. This is the total hours in which we utilize for the production of X and Y. But I don't know how much units of X is produced. So that's why 1 unit of X takes 8 hours. But I don't know how much units of X is produced. That's why I will multiply with supposed number of units, that is X, plus 10Y. Y is again number of units of product Y is equal or less than 11,000 hours. This is your hours. Equal and less than, we will assume maximum 11,000. So the hours available to us is 11,000 hours. Now, for the department B, we will also make the equation same way. How much labor time is required for the 1 unit? That is 4x plus, again 10y is equal or less than 9,000 hours. Now, department C, how much hours take? That is 12x plus 6y equal or less than 12,000 hours? Yes, please, if anyone have an okay. Now we have a demand limitation also. There is no limitation for X, but the Y demand is limited. Y is maximum can be sold, that is 600 units. Okay, Y is equal or less than 600 units. And the most important thing in linear programming is non-negativity constraints. We have to take this assumption and must mention this assumption, X units of product X and Y is greater than or equals to 0. Production can never be negative. It not be in -1, -2, -3. So that's why we assume our production may be 0 or more than 0. 1, 2, 3, 4, 5, 6, 7, onward units. Okay. So this is how we will formulate our constraints. Any question relating to the constraint formulation? Clear?
Yes.
Okay, done. Now we have to draw the graph. For the drawing of the graph, we first solve these all constraints. Then we were able to solve the graph. The assumption taken of this that the non-negativity constraint assumption is taken for solution of graph. That's why the step 4 is draw the graph. For drawing of the graph, what I do, I have to first of all solve all the constraints. For department A, constraint is 3x plus 10y equals to 11,000 hours. I said greater than or equal, we suppose it is equal to 11,000. And I will suppose if x is equal to 0, if I produce no units of x, then how much units of y is produced? So this figure becomes 0, 3x 0 plus 10y is equal to 11,000 hours. So how much units I can produce for the y? 11,000 hours, and for 1 unit they take 10 hours. How much unit? I can produce 110 units. Sorry, 1100 units. Sorry, not 110. 10 cancelled. Okay, 1100 units. I will produce the 1100 units of product Y. If I produce no units of X, then how much maximum units of Y is produced is 1100 unit. This is maximum units which we can produce if no unit of X is produced. Now I will find the X units. If Y is equal to 0, then what is the equation? Equation is 3x is equal to 11,000. X is equal to 11,000 divided by 3. So now tell me how much units?
Is it 3 or 8?
Oh, it's 8. Oh, it's 8. Here I write 3. That's why we are going to stay 8. It's 8x. Okay. So how much units?
137. 1375, sir.
1375. Done. Units. Okay. Now we will solve it for the department. Our next department, that is department B. Now I will solve it directly, department B. The equation is 4x plus 10y is equal to 9,000. If x is equal to 0, then y is equal to 900 units. If y is equal to 0, then how much units of x? 9,000 divided by 4. It becomes 8 units. Okay. These are the units. So for the department C, now for the department C, what are my units? Equation is 12x plus 6y is equal to 12,000. So y is equal to 12,000 divided by 6. It's 2,000. 2,000 units of y. And for x, how much units? 1,000 units. X unit is 1,000. Yes, clear? These are my points which I use for the drawing of the graph. So I should write these points and set aside. Why? Because when I draw the graph, I need these points. For the department A, equation is 8x plus 10y, and x unit is, y unit is 1100, x unit is 1375. 4x plus 10y unit is 900 and 2280. For next department, it is 2,000 and y is 2,000 and x is 1,000 units. Now I will draw the graph. We are not using graph paper. It's just a rough sketch to understand how the graph is drawn. Okay. Here I will have product X, and on y-axis I have product Y. Okay. This is y-axis, this is your x-axis. This is origin point. Okay, if I draw the first equation, my first equation is 8x plus 10y is equal to 11,000. I want to draw this equation. If x is 0, how much units of y I have produced? Let's suppose, how much is my maximum units? My maximum units, I think so, 2,000, no, 2280. 2280. So I will suppose accordingly, it start from 1,000, 1,100. Let's suppose I start from the 1,000, then no, 1,100, no. Then 1,200, take the gap of 1,400, 1,600, 1,800, 2,000, 2,200. and this is 2400. Same I will draw, that is 1000, 1200, 1400, 1600, 1800, and 2000, 2200, and 2400. Okay. If x is equal to 0, then how much units of y I am going to produce? That is 1100. 1100 is mid. This is the point of 1100. My graph will become very short because we expose wrong. We will start from the 500. Okay, let's just draw. Now 1100. This is your 1100 point, and then third, if y is 0, then x is 1375. Approximate it is like here. I will join these 2 points and write equation here. These joins and write the equation 8x plus 10y is greater than or is less than or equals to 11,000. Okay. Now for the next department, I have to produce 1200 or 900 units. Okay, this is your 900 point, and then 2280. It becomes here. So we will draw the line. The graph is very much towards the x-axis because we have taken wrong scale. We start from the 500, then we will do upward movement, then it will be right. Okay, just understand the points, how the points are drawn. I will show the complete graph again. Okay, now next is y is equal to 1200 units. It's 1200 point. And no. Y is equal to 2000 and 1000. If x is equal to 0, y is 2000, y is 2000, and 1000. X is 1000. This is the point. We will draw these lines. And there is also a point, y is equal to 600. Y is equal to 600. So the 600 point lies approximate here. This is your graph. I will show the right graph, how the graph looks like. This is the graph which is given in the exam. Okay. It starts from the 100 and go up to 2000. Okay. And maximum units of x is 2280. That's why it goes up to 2000 more units. Okay. 2500. The lines are drawn here. Department A. See the department A. This is the department A. This is your department A equation drawn. In department A, I have how much unit? Y is 1100. This is 1100 point. And X is 1375. So it's little bit here before 1400. So we match these two lines and put the equation department A. Now for the department B, I have how much units? 900 units. This is your 900 point, and 2280. This is your 2280 point. We match these with the scale and put the equation 4x plus 10y is equal to 9000. Then for same equation is drawn for the department C equation. This is your department C, because in department C units are 2000. This is the 2000 point, and then your 1000. This is your point. This is your department C equation, that is 12x plus 6y is equals to 12,000. Okay, this is my equation. And this is demand function, y is equal to 600. This is your graph. Now, what is, you have to identify the feasible region. Feasible region means where you suppose there is maximum constraints, or where you see the maximum constraint lies. This is the feasible region. We assume the production is possible only in the feasible region. So if you see, I have this area, this area, this area, and this area. Possibility is that this may be your feasible region, this may be your feasible region, this may be for feasible region. I said where the maximum constraints are satisfied, that is my feasible region. If I see this, there is only, here I have department B constraint, department A point, but demand, department, same demand and department B and department. Okay. So this is not your feasible region because there is no maximum constraint satisfied. Again, this is not my suitable for me. Why? Because here only two constraints are satisfied. So that's why, which I assumed, and in case of maximization of contribution, the feasible region is towards x-axis. Okay. So this is your feasible region. This is your feasible region. In exam, feasible region is already identified. This is your feasible region, and I assume that points, corner points. This is point A. This is your point E point. This is your point B. Okay. This is my point C. I see the corner points or intersection points. This is my point C. This is my point D, and this is my point E. Okay. So I assume the points, that is A, B, C, D, and E. Why I assume these points? Because my optimal production is supposed to be lie in all 5 points. In any of these 5 points, that is my optimal production. Okay. There are two methods to solve the optimal production. Two methods to solve for the optimal production. One is the ISO contribution line. ISO contribution line is a supposed line, just imaginary line. Through the ISO contribution line, we can find out our optimal point. And the second one method is simultaneous equation method. In simultaneous equation, the corner points which I assumed, all corner points which I assumed, I will solve the using simultaneous equation method and find at which point my contribution is maximized. So if I suppose the ISO contribution line, I suppose my maximum contribution, I just suppose my maximum contribution by imagine. Okay. Suppose any equation, contribution equation. What is your contribution equation? Contribution equation is 12x plus 8y. Assume any units of x and y which must lie in the feasible region. He assumed x 800 and y 400. So what is your maximum contribution? Yeah, in other words, we will assume a contribution. Let's suppose a contribution. I assume my contribution maybe 24,000. I just suppose contribution is 24,000. Just suppose. If I suppose 24,000 divided by 12. No, it's too much. It's 2,400. Hmm. 24,000 is too much contribution. My physical units exceed the feasible region. Assume the contribution within the feasible region. Let's suppose I suppose my contribution is 2,800. Let's suppose our contribution is 2,400. Okay. If my contribution is 2,400, C is 2,400. How I will solve the equation? I put the C 2,400, 12. If units of X is 0, then how much units of Y is produced? So I will find the units of Y. 2,400 divided by 8. How much units of